welcome back, and thanks for clicking on another Pre-Narculus production. Yay! Today we are going to be talking about exponential growth and decay along with Half-Life, which you probably remember doing in chemicals class, right? The one with chemicals, chemistry. All right, so let's talk about first the law of exponential behavior. This law should actually look pretty familiar to you. The equation is given as A is equal to A naught e to the kt. This is read as A naught, okay, A sub 0, e to the kt. This is very familiar because it looks almost like APERT, A equals P e to the RT that we just learned about for compound interest, right? And if you look at the variables and what they represent, they're very similar to this APERT equation that's up here. Okay, A is the amount after some time t. A naught is the initial amount, just like P would be. P would be the principal, right? The amount that you invested. K is the constant of proportionality. So with these problems, you're going to go find K first. Then you're going to be able to answer the question. Okay? And then time, t, is in any consistent unit. So t represents the time. This should be a lowercase t. In any consistent unit. So a little bit different from APERT, right? APERT, t was in years. Okay? Here, the time can be in any unit as long as it's the same unit across the whole problem. So if you want to do it in days, fine, but everything has to be in days. Every time you do the problem, t has to be in days. Okay? So for these problems, pretty much what we're going to do is we're going to find k first, and then we're going to use that value of k in our new equation to go and actually figure out something else. All right? Okay, so let's try one here. So in a research experiment, a population of fruit flies is increasing according to the law of exponential growth. Okay, so we already know that A equals A naught e to the kt. All right, so we're going to have to find A naught, K, and T. Okay, after 2 days, there are 120 flies. If there were 10 flies initially, how long would it take for there to be 500 flies? So this is the question we want answered. But to do that, we need to know what K is. There's no K listed in this problem. But we at least have to be given enough information to go and find K. So let's talk about what we have with the information that we're told. We're told that after 2 days, there are 120 flies, and there were 10 flies initially. So A naught is 10. That's the initial number. Okay. After there were 120 flies, it took 2 days. And it doesn't matter that time is in days. That's allowed, okay, for this equation. All right? Because we're not talking about an interest rate, a yearly interest rate. Okay, so this is enough information to find K. The only variable left is K. So let's go do that. So we have our equation here, A equals A naught e to the kt. So we would have 120 equals 10 e to the 2k. Okay, we got to solve for k. So divide by 10 on both sides. We get 12 equals e to the 2k. Take the natural log on both sides to get the power down. So that's going to be 2k ln e. Oops, let's erase it. We'll do one extra step. Okay, so we have ln e to the 2k. That lets us put the power in the front. So we have ln 12 equals 2k ln e. But ln e, that's 1. So k comes out to be ln 12 over 2, right? Or 1/2 ln 12, all right? Which we can approximate. We're going to use 6 decimal places to approximate it to 1.242453. Okay, 6 places after the decimal. All right, now let's go answer the question. It says, how long will it take for there to be 500 flies? Okay, how long? So that means we want to know t. All right, so let's reset this. We have our equation, A equals A naught e to the kt. A naught, K, and T. All right, so K we have, this is K, it's going right there. A naught, initially there were 10 flies when we started. After, there's going to be 500 flies, and I want to know how much time it takes to do that. Okay, so then we plug the numbers in. We have 500 equals 10 e to the 1.242453 t. All right, solve for t. Divide by 10 on both sides. We have 50 equals e to the 1.242453 t. Take the natural log on both sides. Let me erase some stuff over here so I can keep going here. Give me 1 second. Let me just erase some stuff here so I got enough room. All right, there we go. So take the ln on both sides. We have ln 50 equals 1.242453 t times ln e. Ln e is 1. Divide by 1.242453 on both sides. 242453. And we get t comes out to be 40.2429. And that's in days. Why? Because we started in days. These were our units, days. So days will stay consistent through the whole problem. And there's our answer. Okay, so the process is find K first, figure it out, then go answer the question. All right, let's have a conversation here about half-life. Half-life is the time it takes for a substance to decrease by exactly 1/2. Makes sense, half-life. Okay, all right, so let's take a look at one that involves half-life. Half-life also uses the same equation, A equals A naught e to the kt. Okay, a substance has a half-life of 30 years. How much of the substance, weighed in grams, will remain after 237 years? So this is the question. How much will remain after 237 years? The half-life is 30 years of this substance. All right, so let's start with our equation. A equals A naught e to the kt. We have A naught, K, and T. Oops, and put it over here for convenience. Okay, all right, so we want to find K. Well, we know the half-life is 30 years, but what does that mean, half-life? Well, it means that exactly half of what we started with would be left after 30 years, right? So if we started with 10, then after 30 years, 5 is left, okay? If we started with 50, after 30 years, 25 would be left, exactly half. Now, it doesn't say how much we start with here, but that's okay. We can just make anything up. So let's just say we started with one substance. Okay, how much would be left after the 30 years? Half of it, 1/2. That's enough to find K. All right, so let's plug them in. We got 1/2 equals 1. We really don't need the 1. To the 30 K power. We divide by 1. We really don't need the 1 at all. We get 1/2 equals e to the 30 K. Take that natural log on both sides to get the power down. You get K is ln 1/2 over 30. Okay, which is approximately, we have approximately negative 0.02310. All right, 2 zeros at the end there. So this is our value of K approximately. Okay, so now we want to know how much will be there after 237 years. So we found K. So let's go back and start again. A naught, K, T. Now the time is going to be 237 years. Here's K. Here's K. We'll use that. Put that in over there. Okay. How much did we initially start with? We're saying we started with 1. We don't know how much there is after though. So A is equal to 1 e to the negative 0.02310 times 237. Now, if I were you, I'd multiply these two out first, then take e raised to that power. And if you do it correctly, you get 0.0042 grams. Okay, so almost nothing is left after 237 years. Almost nothing. 0.0042 grams. Okay? Now, I want you to understand that it really didn't matter what number you started with for A0. So let me just show you here real quick. All right, let's say I said, oh, well, all right, I started with 25 grams, or no, not 20, we'll say 20 grams, okay? If I started with 20 grams, then after 30 years, there'd be 10 left, right? There would be 10 left. So let me come erase this here, and I'll show you what happens. Okay, you can see it here momentarily. So let's take these numbers, plug them in. I'm finding K. So I'd have 10 equals 20 e to the 30t. Divide by 20 on both sides. And you get, well, that line. Oops, there should be a K, not a T. Sorry, folks. I'm solving for K. Okay? So I divide by 20 on both sides. What do I get? I get this line that's right here. 1/2 e to the 30k. So it doesn't matter how much you write in the initial spot, as long as afterward, okay, after the half-life of 30 years, there'll be exactly half of what there was. All right? Now, half-life isn't always 30 years. Could be any number of years. Okay? It depends on the problem. All right? And that's how you would do a half-life problem. So again, in summary, for these problems, the first thing you do is you find K. Use your information to find K. Then use K and the information to go figure out what it is that you want. All right? And that's pretty much all there is to it. And now, here's one for you to try. Okay? And just so we're clear, that's choice A, that's choice B, that's C, and that's D. All right? When you're done, you're all done. As always, thanks for clicking.